Okay, I just want to talk about question 6 right here. They're going to give you the value for one of the trig functions of theta, and then a restriction that the cosine is less than 0. And you'll see why that's going to be important for in a second. And then they ask you to just find the sine, the cosine, and these reciprocal trig functions. Those are new. Those you haven't seen on Khan Academy, but they're really easy. I'll show you in a second. So to do this, all we have to do is create the right triangle, right? We know that tangent of theta is 3 times the square root of 5 over 2. And we know that tangent is equal to the opposite over the adjacent. So we just create this right triangle where here's theta. That's a pretty poor looking theta, but that's theta. And then we have the opposite being 3 times the square root of 5. And then 2 is the adjacent. Okay? And what we're going to do now is just find the hypotenuse, right? Because that'll allow us to find the sine and cosine. So we just use the Pythagorean theorem to do that, which is just always a squared plus b squared is equal to c squared. The hypotenuse squared is equal to 2 squared times 3 times the square root of 5 squared. If you work it all down, you get down to 7 for the hypotenuse, okay? So that gives us our right triangle, okay? Now what we have to do is figure out which quadrant the triangle's in. And this, we have like a couple different options here, right? There's 4 quadrants: quadrant 1, quadrant 2, quadrant 3, quadrant 4. I've drawn the triangle in all 4 quadrants. Notice saying quadrant 2, right? This is -2 because it's going 2 in the negative direction, right? But it's still positive 3 times the square root of 5 because it's in the positive y direction. Whereas over here in the quadrant 3, it's -2 in the x direction and -3 times the square root of 5 in the y direction, okay? Now we know our tangent of theta is positive, so that tells us that we're either talking about the quadrant 1, where the tangent of this angle theta would be 3 times the square root of 5 over 2, or we're talking about the quadrant 3, where you get negative 3 times the square root of 5 over -2, but the negatives, both numerator and denominator are negative, so they cancel. Okay, so it ends up being positive in the third quadrant. Okay, so we're between these two triangles. We can discard quadrant 1 and quadrant 2 or quadrant 4. Now, what's going to help us pick between quadrant 1 and quadrant 3 is that we know that the cosine's less than 0. It's negative. Okay. Now, the cosine over here, remember cosine is just adjacent over hypotenuse. So that's 2/7. That's positive. So it's not going to be quadrant 1. And we just check to make sure it's negative in the third quadrant. It'd be -2 over 7. That's negative. So that lets us know that this is the quadrant we're talking about. This is our triangle right here. And so I'm going to redraw it just with that one triangle. Okay, I've gotten rid of the other quadrants as not possible options for us. And once you know the triangle sides and you know the quadrant that it's in, it's easy to calculate the sine, cosine, and all the other things for it. So the sine is just right the opposite over hypotenuse. So -3 times the square root of 5 over 7, right? Cosine is just, I think we already even computed this, right? Is adjacent over hypotenuse, so -2/7. And here's the part of the question that might have been really confusing for you because you haven't seen this at all yet. Secant is actually 1 over cosine. It's really just a flip, if you think about it, of whatever cosine is, whatever fraction cosine is, the secant is the flip of it, okay? And so here are the reciprocal identities. I think on the question it asks for all of these. So really, when you get to the cosecant, you just have to flip the sine fraction over. So the cosecant is really just going to be 7 over -3 times the square root of 5. Of course, you probably put the negative up with the 7 just to make it look good. Secant we already talked about. Cotangent is just going to be the flip of on whatever tangent is, right? So if tangent is this, then the cotangent is just going to be 2 over 3 times the square root of 5. So I hope that helped a little bit with this question. I know there's a little bit, a little something new on there with these reciprocal trig functions, but there's not too much computation and not too much heavy lifting to get those right. You just have to flip the fractions over.